Kinetic molecular theory of gases. Gas laws like Boyle's law, Charles' law, etc. were based on experimental observations and they were not based on any theory. Okay, so in order to explain the general behavior of gases, Maxwell, Boltzmann, and others put forward a theoretical model of gas, and this theory is known as kinetic molecular theory of gases. Kinetic molecular theory of gases or microscopic model of gases. Microscopic model of gases. Why we call this theory the microscopic model of gases? Because the postulates are related to there are different postulates for this theory, and these postulates are related to atoms and molecules. So they are called as microscopic model of gases. Now let us discuss different postulates one by one. First point, all gases are made up of large number of extremely small particles called molecules. Okay, all gases are made up of extremely small particles called gases. And also they are considered as point masses. Okay. Second point, molecules are separated by large distance with one another. Okay. So molecules are separated from one another with large distances. Okay, so due to these large distances, the actual volume of molecules is negligible as compared to the total volume. Okay, actual volume of molecules is negligible as compared to total volume of the gas. Okay, so gases are compressible. Next point, there is no force of attraction between the molecules of gases. Okay, there is no force of attraction between the molecules. Okay, so these gases are expand and they occupy all space available for them. Okay, so they expand and occupy all available space. Okay. Now, next point. Molecules are always in a state of continuous rapid motion in all directions. Okay. Molecules are in a state of continuous rapid motion. In all directions. Okay, so during this motion, they keep on colliding with one another and also with the walls of the container. Okay. Now, next point. Molecular collisions. These molecules, while collision, they are perfectly elastic. That is, molecular collisions are perfectly elastic. Molecular collisions are perfectly elastic. That means there is no net gain or loss of energy in their collision. Okay, that is there is no loss or gain of energy. Loss or gain of energy during their collision. Okay, so during these collisions, they exchange the energy between the colliding molecules. Okay, so their individual energy may change, but the sum of the energies remains constant. Okay, they exchange energy during the collision. That is, molecules exchange energy during the collision. Okay, so their individual energies are different. But the sum of the energies remain constant. Okay. Next point. The pressure exerted by the gas is due to the bombardment of molecules with the walls of the container. Okay. The pressure exerted by the gas is due to the bombardment of molecules with the walls of the container. Okay, so on heating a gas, what happens? Its kinetic energy increases. Okay, so the bombardment of these molecules with the walls of the container increases, so they exert more pressure. Okay, on heating a gas, kinetic energy increases, so they exert more pressure. Now, next point. At any instant, different molecules possess different velocities, so they have different kinetic energies also. Though the individual speeds are different, the distribution of speed, that is the total speed before collision and after collision, remains constant at a particular temperature. Okay, so at any instant, different molecules have different velocities, so they have different energies. Okay, so though their individual speeds are different, the distribution of speed or the total speed remains constant at a particular temperature. Okay. Next point. So if a molecule has variable speed, there must be variable kinetic energy. Okay. However, the kinetic energy of the molecules are directly proportional to the absolute temperature. Directly proportional to the absolute temperature. Okay. Next, so these are the different postulates of kinetic molecular theory of gases. Okay. So the calculations and predictions based on this theory agree very well with the experimental observations. So this established the correctness of this theory. Okay. So this theory is applicable to all types of gases.